everyone, my name is NUR ALEYSHA and I'm from F1T3. So today I'll be explaining past year chapter 4 question 6A and B. 6A. By using Lewis dot symbol, show the formation of the compounds boron trichloride and lithium chloride from their respective atom. Identify the type of bond in each compound. Explain the hybridization state of the central atom in boron trichloride molecule. State its molecular geometry. So first, they want us to show the formation of the compound by using Lewis dot symbol, and then they want to identify the type of bond in each compound. After that, they ask us to explain the hybridization state of central atom in boron trichloride and also its molecular geometry. So usually for this kind of question, they will allocate around 10 marks. Okay, for lithium chloride, central atom is lithium, total valence electron 8, and this is the structure. So lithium will donate 1 electron to chlorine. So after that, lithium will be cation as it donate 1 electron, and chlorine will be anion as it receive 1 electron to become octet. So the type of bond here is ionic bond or electrovalent bond. As for the marks, 1 mark will be given for the drawing and another mark will be given for correct type of bond. Next, for boron trichloride, the central atom is B, total valence electron 24, and this is the formation for boron trichloride, and the type of bond is covalent bond. So again, 1 mark for the drawings and the other mark for the type of bond. Next, for boron trichloride, we have to draw the molecular geometry and also name it. So the name for this molecule is trigonal planar. The electron pair arrangement is also trigonal planar. The bond angle between the molecule here is 120 degree. Next, the type of hybrid is sp2. So 1 mark will be given for the drawing and the name, and another mark for the type of hybrid. Okay, for central atom B, we have to draw the orbital diagram here. So this is the ground state, excited state, and hybridized state. So based on the Lewis structure of boron trichloride, central atom is surrounded with 3 bonding pair electrons. The ground state of B atom shows that B atom needs 3 unpaired electrons to form 3 sigma bond. 1 electron from 2s orbital is excited to empty 2p orbital to form 3 unpaired electrons. The 2s and 2p orbital are hybridized to form a set of sp2 degenerate orbital, and this is the empty 2p orbital. So 2 marks for the orbital diagram and another 2 marks for the explanation. So the one that I highlight down here is the main part, the main idea for this part. B. Formic acid is widely used in the preservation of biological specimens. Its chemical structure is shown below. Draw and describe the formation of bond by involving the overlapping of orbitals. What is the possible intermolecular forces that exist between this acid molecule? This question usually carry around 10 marks. Okay, so the first 2 sentence up here is just the information. So the main task that they ask us to figure out here is to draw the formation of bond, and then they want us to describe number 1 or describe it, and then determine the possible intermolecular forces that exist between this acid molecule. Okay, so I redraw the structure here and I label it as O1 and O2. So the molecular geometry is trigonal planar for the whole thing, and the type of hybrid is sp2. Okay, the intermolecular force here in this molecule is intermolecular hydrogen bond around here. So actually in this molecule, there's 2 molecular geometry. So the first one is the main one. The first one is the main one, and the second one I'll show later. That's why I label it as O1 and O2. Okay, for central atom C, this is the ground state, excited state, and hybridized state. And this is for terminal atom and O2 atom. Okay, I redraw the structure because I want to label this element. This is O1 and this is O2. So the name for this molecule is trigonal planar. The electron pair arrangement is also trigonal planar. The type of hybrid is sp2, and the intermolecular force is intermolecular hydrogen bond that happened here. So 1 mark will be given for the name and for the type of hybrid, and another mark for the intermolecular force. Okay, this is the orbital diagram for central atom, ground state, excited state, hybridized state. And this one is for terminal atom. This is the terminal atom for O2. 1 marks will be given for orbital diagram for central atom, and 1 marks will be given for the correct orbital diagram for terminal atom and for both terminal atom. Okay, for O1, I redraw the structure because as you can see here, there's 2 lone pair, so the molecular geometry will change. So the new electron pair arrangement is actually tetrahedral. Type of hybrid is sp3. So for central atom here, O1, this is the ground state, and this is the hybridized state. And for terminal atom H, this is the ground state. So 1 mark will be given for correct type of hybrid, and another mark for the overall orbital diagram. This is the drawing for hybridization of formic acid. So 2 marks will be given for the whole drawing, 1 for the overall shape, correct shape, and another 1 for labeling for each part, everything here. This is the explanation for the drawing earlier. The first 2 points here is the most important thing. The hybridization of carbon atom is sp2, and the hybridization of O1 atom is sp3. So the sp2 hybrid orbital of carbon is overlapped with 1s orbital of H atom to form sigma bond, the first sigma bond. The sp2 hybrid orbital of carbon is overlapped with sp2 hybrid orbital of O2 atom to form sigma bond. The sp2 hybrid orbital of carbon is overlapped with sp3 hybrid orbital of O1 atom to form sigma bond. The sp3 hybrid orbital of O1 atom is overlapped with 1s orbital of H atom to form another sigma bond. The unhybridized 2p orbital of carbon atom, this one, is overlapped with the unhybridized of O2 atom to form pi bond. So 2 marks will be given for explanation. So that's all from me. Thank you.
If you like this video, don't forget to subscribe, like, and share. Thank you.